On the southern tip of South Korea is the town of Okpo. This is where the world's largest industrial vessels are produced. And the way they do it is incredible. Traditionally, ships were made from the bottom up, but not here. At this shipyard, a ship is put together more like Lego. 85 separate blocks, each one weighing around 400 tons, are joined together one at a time. This is Lego for giants. The workers at the Daewoo Shipbuilding and Marine Engineering Shipyard are deservedly proud of the 40 ships they make each year, because these are the Trojans of the sea. And they don't take their work lightly. Every day starts with morning exercises. The blocks look like they've been cut straight through the middle with a saw, and in a way they have. But not by hand, by computer. Every new design of ship is broken down into precise and detailed three-dimensional sections, like blueprints. It's called cyber fabrication, and it makes finished individual 50-meter blocks, ready to go. All you have to do is put them all together. But what happens if one steel sheet is cut a centimetre too wide, or welded in slightly the wrong position, or fitted together just out of place? The finished block will not fit the jigsaw, and that costs, well, a ship. So how do they make sure every part of the process achieves the accuracy needed for this system to work? Introducing the plasma cutters, the tailors of steel. The pattern on each plate is transmitted directly from the computer. It's mapped out on the plate first, then cut using a device a bit like a welding torch. The different sections are then given an individual number and sent on their way. Working to an exact blueprint means this is shipbuilding by numbers. In the assembly shop, if the cyber fabrication system is working, all the cut steel plates should slot exactly into place. Still, there is a little coaxing to be done. The steel slabs need to be winched tightly into position, then locked using hydraulic clamps. As they make their way down the assembly line, each new section is added piece by piece, resulting in a massive 50-meter finished block. Moving the blocks into position is down to the keen eye of the workers. Making sure they stay in position is down to the welders.
All products like oil, gas and cars are carried by ships. To make one ship takes 1 million sections of steel, all put together by welding.
The quality of welding is crucial to building a modern vessel. If a breach occurred and the weld was not watertight, it could potentially sink the ship. However, there are some places that even the tiniest of welders cannot reach. Only one thing is up to the job: a robot. These are automatic welding robots. They can squeeze into the smallest spaces. And they get commands from the main computer. over 1,000 control programs translate information about type and depth of weld. As the blocks are finally assembled, man and machine work side by side. But once it's finished, how do you move a 50-metre, 400-ton block to the dockside? These transporters may look like something out of Thunderbirds, but they're the cool solution to the problem of carrying the blocks around the shipyard. Each transporter has its own safety warden cycling ahead of it to keep traffic out of the way. This method of putting all the blocks together at once is only possible with a combination of precise measurement, designed through cyber fabrication, and the world's largest Goliath crane. At over 120 meters high and 150 meters wide, it can lift weights of up to 600 tons. It's so big that just the letters on the top are the length of a bus. Its job is to lift the assembled blocks and drop them precisely into position onto any one of the 5 ships that are being made in the dock. To get there, this lumbering giant moves 300 meters along a rail track, shifting other cranes out of its way as it goes. Now the block is ready to just slot into place. However, here is the moment of reckoning. Will it fit? Have all the parts of this cyber-fabricated ship been made accurately enough? And how do they fit it together without leaving any gaps? Measuring the position and specific size of the ready-made block is done using special 3D equipment. This identifies 3 coordinates on an X, Y, and Z axis by locating targets placed on the block. These coordinates are fed into the computer and compared to the cyber design. The tiniest error in measurement must be corrected and the block pulled into position, even if it's just a matter of millimeters. The final gaps between the blocks are sealed by welders. Finding out whether the ship is actually watertight, we'll have to wait for the launch. It will take 3 years to put all 85 blocks together. Only then will this ship be named, launched, and sent on its way. Then another single block will take its place, and the whole process starts again. Five ordinary objects, 5 extraordinary stories. Coming up, they're miniature marvels of engineering, yet to work they rely on a rock that dates back to the dawn of time. The secrets behind wristwatches, next on How Do They Do It? Since the dawn of civilization, we have used the measurement of time to order our world. With our finely tuned modern lives, accurate timekeeping has never been more important. But the majority of us take the most common form of timekeeping technology for granted. The story of the wristwatch is a tale of 3 seemingly impossible hurdles. Energy, how to produce enough power for the watch to work. Size, how to fit this into this. And accuracy, how to measure time itself. So, how do they do it? It turns out the best source of super-accurate timekeeping is right beneath our feet: quartz. Quartz is the secret ingredient of modern timekeeping. And incredibly, it's one of the most common minerals on the planet. It makes up around 12% of the Earth's crust and is found on meteorites and moon rock. It is everywhere. However, before it can be used in a watch, it has to be mined. This is the Cytec Open Cast Quarry, north of Quebec City in Canada. It processes 200,000 tons of quartzite every year. The question is, how can a common rock tell the time? Incredibly, quartz has a hidden quality that only reveals itself when under pressure. It vibrates. When compressed, it creates an electrical charge that makes it continuously oscillate, 32,000 times a second. To make use of quartz in timekeeping,